This research was dedicated to mapping relevant variables to the performance of one Capuchin monkey in the delayed matching to sample, or DMTS. This type of task is widely used when the short-term memory is investigated, commonly characterized in terms of storing information for a short period of time until it is needed to perform a task. For example, when someone tells you a phone number and you keep that number until the time to type it. The delayed matching to sample task follows this logic. In this procedure, each trial begins with the presentation of a stimulus, usually called sample. The subject must touch this stimulus. Then, the sample is removed for a period of time corresponding to the delay that longs at least 0 seconds. At the end of the delay, 2 or more stimuli, called comparison, are presented, of which one is the comparison that corresponds to the sample. A response to the comparison stimulus that matches the sample, also called S+, is reinforced by a banana's pellet and starts the intertrial interval, the ITI. Responses to the comparison stimulus that doesn't match the sample, called S-, is only followed by the ITI. Research about DMTS with human and non-human subjects show an increase in the number of errors as the delay between the disappearance of the sample and the appearance of the comparisons is increased. It would be the same as if you only have access to the phone to make a call only a few minutes after you received the number. The longer the time between receiving the number and the needing to use it, the harder it is to remember the number. Research also showed that by increasing the intertrial interval, it has increased the number of correct choices. During the development of previous studies involving the manipulation of the length of delay and intertrial interval, the subjects showed some emotional responses. For example, touching the screen when there was no stimuli. This kind of response impaired their performance. As a measure to avoid too many errors due to these inadequate responses, a pellet was also released during the intertrial interval independent of the responses of subjects. This research aimed to specifically investigate the behavioral effects of independent reinforcement of response on the performance of Tico, a Capuchin monkey, in the DMTS task. Each session of this study was composed by 3 values of delay between sample and comparisons: 1 second, 5 seconds and 20 seconds. And the intertrial interval was 30 seconds. 5 conditions of pellets releasing during the ITI were evaluated. Early, pellet released after 5 seconds of the beginning of the ITI. Middle, pellet released after 15 seconds of the beginning of the ITI. Late, pellet released after 25 seconds of the beginning of the ITI. All 3 pellets released along the ITI after 5, 15 and 25 seconds after the beginning of the ITI. And none, there was no release of pellets along the ITI. We sought to determine whether any of these conditions would have effect on the learning of unknown relations by the subject. In addition to the 5 conditions, 5 sets of stimuli were prepared. Each of these sets was applied in 5 sessions with one of the conditions. For example, the set of stimuli A was presented in 5 sessions in which it was not released pellet. Set of stimuli B was presented in 5 sessions in which the pellet was released at the beginning of ITI, and so on. The data did not indicate a condition of releasing pellets in the intertrial interval which could have an effect on learning new relations. So that during the sessions the subject's performance varied widely and no standard was presented. The lower performance of the subject was in a session of the condition none and set of stimuli A, in which the subject showed a performance of 50% accuracy. We attributed this drop in his performance in this condition to the selected stimuli, so we chose to reapply the condition none with a different set of stimuli, the set F. With this new application has been confirmed that it is likely that the errors in the first application occurred due to the selected stimuli. Apparently Tico's performance throughout the sessions was not affected by release of the pellets in the ITI. With regard to delays, data corroborated the literature as meaning that the increased performance occurs in the shortest delay, 1 second, and more errors occur in the longest delay. In this case 20 seconds. Apparently the condition latest to have the most effect on the performance at delay 20 seconds, followed by condition all. In smaller delays, 1 and 5 seconds, the same effect is not noticed. It seems, in the future, we intend to expose this subject, and others, to a new experimental condition, in which it will be assessed the performance of subjects depending on pellet release at the ITI, but then using sets of familiar stimuli.